Okay, first lesson of the third term. We're going to deal with sequences today. For the most part, we're going to stay within two categories of sequences. There are arithmetic sequences, where there is a constant difference between terms. And we're also going to deal with geometric sequences, where there's a constant ratio between terms. Okay, so just to define a couple things here. Tell you the difference real quick is that a difference means something constantly being added or subtracted to the previous term, whereas a ratio means that the previous term is constantly having something being multiplied or divided into the second term, or the previous term. So here we go. Describe each sequence as arithmetic, geometric, or neither. So looking at sequence A here, I see that if we multiply the previous term by 2, we'll get the next term every single time. Okay, so 1 times 2 is 2, and 2 times 2 is 4, and 4 times 2 is 8, and 8 times 2 is 16. That is a constant ratio. It's a 2 to 1. The next term is always a 2 to 1 ratio with the previous term. Okay, sequence B, which makes it geometric, I'm sorry, by the way. I can see that every term is 2 more than the previous term. It's a constant difference of 2 between terms. That is an arithmetic sequence. Okay, sequence C is consecutive square numbers here. We got 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. That is a neither. Okay, so there's a little example of each. It is not geometric and not arithmetic. Okay, what is the constant difference in this sequence? 1, 5, 9, and 13. I think you guys will quickly be able to identify that that is a difference of 4 between every single term. Okay, what is the constant ratio in this sequence? 5, 25, 125, and 625. Again, I think you'll quickly be able to tell you, especially since I told you it was a constant ratio. It is a ratio of 5. Each term is being multiplied by 5 to get the next term. So if we wanted the next term after 625, we'd take it and multiply it by 5. Okay, and last thing for today, and I guess what most would assume is the most confusing part of today, we're going to write the first, I should say 4, I'm sorry, first 4 terms of the sequence described by each formula. Now the first thing is, this looks a little bit weird here with this a subscript n right there. But a subscript n means the value of the nth term. So a subscript 1 would be the value of the first term. A subscript 2 would be the value of the second term. Now what this says here on F here, this formula, says the value of the nth term is equal to 2 times the number of the term. The value of the nth term is equal to 2 times the number of the term. So term 1, we'd go 2 times 1. Term 2, we would do 2 times 2. And term 3, we would do 2 times 3. And term 4 would be 2 times 4. So you just take the term number and multiply it by 2, as indicated in the formula. So our first 4 terms are 2, 4, 6, and 8. Okay, now on sequence formula G here, it says the value of the nth term is 2 to the nth power. The value is the nth term is 2 to the nth power. So in other words, we're going to take 2 and raise it to the first power for the first term, raise it to the second power for the second term, third power for the third term, and fourth power for the fourth term. So these are the first 4 numbers. 2, 4, 8, and 16. Okay. So we've got a couple of examples of how to do this. It's going to show up in your problem sets here over the coming days, and we'll get this down, and we'll come to understand this terminology a little bit better as well. All right. Have a great night, and we'll see you tomorrow. Make sure that as this term goes on, that you're finishing all problem sets every single day, watching all videos, and watching them more than once if need be. We're going to have a great and successful term. See you tomorrow.